Hello grade 11 American System, this is Mrs. Nancy. Today I'm going to start a new section 17.1, the flow of energy. The objectives of this section are: explain the ways in which energy changes can occur, explain how the energy of the universe before a chemical or physical process is related to the energy of the universe after a chemical or physical process. So please open your books, page 556. Energy is the capacity for doing work or supplying heat. So a car moves because of the energy supplied by the fuel. Thermochemistry is the study of energy changes that occur during chemical reactions and changes in state. So every substance has a certain amount of energy stored inside it. So the energy stored in the chemical bonds of a substance is called chemical potential energy. So during a chemical reaction, a substance is transformed into another substance with a different amount of chemical potential energy. So energy changes occur as either heat transfer or work or a combination of both. Heat is energy that transfers from one object to another because of a temperature difference between the objects. Heat, for example, flows from a warmer object to a cooler object. So if two objects remain in contact, heat will flow from the warmer object to the cooler object until the temperature of both objects is the same. Endothermic and exothermic processes. In general, chemical reactions and changes in physical state generally involve either the absorption or the release of heat. So you can define a system as the part of the universe in which you focus your attention, and everything else in the universe makes up the surroundings. The law of conservation of energy states that in any chemical or physical process, energy is neither created nor destroyed. So during any chemical or physical process, the energy of the universe remains unchanged. Direction of heat flow. Heat is absorbed from the surroundings in an endothermic process. So in an endothermic process, the system gains heat as the surroundings lose heat. So heat flowing into a system from its surroundings is defined as positive. Q has a positive value. While an exothermic process is one that releases heat to its surroundings. So the system loses heat as the surroundings gain heat. So heat flowing out of the system into its surrounding is defined as negative. So Q has a negative value. Sample problem 17.1. On a sunny winter day, the snow on a rooftop begins to melt. As the melted water drips from the roof, it refreezes into icicles. Describe the direction of heat flow as the water freezes. Is this process endothermic or exothermic? So, as we studied before, heat flows from a warmer object to a cooler object. So an endothermic process absorbs heat from the surroundings, and an exothermic process releases heat to the surroundings. So first, let's identify the system and the surroundings. Surroundings: air, system, water. So in order for water to freeze, its temperature must decrease. So heat flows out of the water and into the air. So because heat is released from the system to the surroundings, the process is exothermic. Number 1. A container of melted wax stands at room temperature. What is the direction of heat flow as the liquid wax solidifies? Is the process exothermic or endothermic? So first, let's identify the system and the surroundings. The system is wax, surroundings air. So here heat flows from the system, which is wax, to the surroundings air. So the process is exothermic. Number 2. When barium hydroxide octahydrate is mixed in a beaker with ammonium thiocyanate, a reaction occurs. The beaker becomes very cold. Is the reaction endothermic or exothermic? As I said before, identify the system and surroundings. The system, chemicals within the beaker, and the surroundings, beaker and the surrounding air. So, since the beaker becomes cold, this means that the heat is absorbed by the system from the surroundings. So the process is endothermic.